What if I were to tell you that the very atoms inside you hold vast amounts of energy? Well, it's true, and it's all because of the strongest force in the universe. It's called the strong nuclear force, and you can think of it as the latex covering of this water balloon. The strong nuclear force holds together the nucleus, the center of the atom. The nucleus is made up of two particles, protons and neutrons. These particles are packed tight together in the nucleus. So the strong nuclear force has to exert a lot of energy to keep the nucleus together. But it also means that when the nucleus is broken apart, a ton of energy is released. The splitting of the atom is called nuclear fission, and it holds the possibility to solve the energy crisis. But how do we break those atoms apart? Let's return to the balloon. Think of the balloon as the nucleus of an atom. The cover of the balloon is the strong nuclear force. The water, the protons, and the pebbles, the neutrons. As you can see here, when a rogue neutron hits the nucleus, it explodes, releasing a ton of energy. Now, with pebbles and balloons, it makes sense how we can pop a balloon, but the mechanisms are a little bit more complicated in nuclear fission. When the neutron strikes the nucleus, it causes the already unstable nucleus to stretch and thin around the middle, forming a dumbbell-like shape. This pulls a large number of particles out of contact with one another, allowing for the strong nuclear force to be overcome and the nucleus to be broken apart. The neutrons released through this process go on to split other nuclei, releasing more neutrons. And those neutrons go on to split even more nuclei. This happens again and again and again. This is called a chain reaction, but not all nuclei can form a chain reaction like this. It's only a specific group of nuclei that can undergo this type of fission. Why? Well, neutrons cannot split the nuclei of small atoms, as the strong nuclear force is much more powerful than these smaller atoms. As you can see here, it's very hard to pop this water balloon, compared to this much larger water balloon, as the water and pebbles in the larger balloon put much more strain on the latex cover. This is why uranium, the largest naturally occurring element, is most commonly used in nuclear fission. Also, if I poke a hole in this balloon, making it unstable, it pops much more easily. This is why radioactive and unstable elements are used in fission. Case in point, uranium-235 is the most used element in nuclear fission. Nuclear fission opens up a world of possibilities for energy. Using nuclear fission, we can develop more efficient nuclear power. It can also provide a cleaner future for the environment. In the meantime, I had to figure out what to do with this water balloon. Thanks for watching.